just be aware, Leah, that the first set of pages, I forgot to get rid of the comments that I made to myself. So just ignore the first set of notes, and I've reprinted it for you. All right.
Hey, ready to walk in? Are we walking in today?
Joseph.
We're not.
I'd have to pull it back up. Does anyone remember off the top of their head if Joseph was in their group for the project?
I was
Bryson and who else? And Josh. Okay. So Joseph, Josh, Bryson, Josh, or Joseph, I can talk about it with you later. But we got to get started with today. We'll talk about AP Classroom separately. Part B and C. Yeah. So we're going to look at the homework problems. She did a Unit 5. She had a Unit 5 question, not the current unit. Yeah. We haven't done AP Classroom stuff yet, so don't sweat that. All right. So we're looking at Chapter 8, confidence intervals for a single proportion. We're going to do a quick recap. So as a reminder, how is this chapter different from Chapter 7? What was Chapter 7 all about?
We're going to use
sampling distributions, right? Remember, Chapter 7 was all about sampling distributions. But what do we have to know in order to actually have a sampling distribution?
parameter.
Not just the parameter. What do you need to get the parameter? The population, right? Sampling distributions are built out of the population. We don't actually have the population almost ever, but we can use principles from our sampling distributions to help us understand the parameter a little bit better. So remember, Chapter 7 assumed that we had the population. We don't have the population. And so as a quick note, that's why yesterday we looked at the detail of, can I ever actually really use sigma sub x bar? No. We haven't done x bar yet. We'll do that tomorrow, or next unit. Sigma sub p hat, the standard deviation of the sample proportions was what? It's the square root of something. P times 1 minus t divided by n. But remember, that's based on having, what does p without the hat mean? That's the population proportion. Do we ever actually have that?
No.
Very, very rarely, right? So yesterday we talked about this, which is very similar, but what's different about this one? That's called standard error. And that standard error is based on not p, but p hat. And if we have an unbiased estimator, should this be pretty similar? Yes. That's the whole idea, is that they should be similar, understanding how sampling distributions work. They're just not going to be exactly the same.
We're gonna have to check if it's an unbiased estimator.
P hat is an unbiased estimator,
Alright.
right? So P hat is an unbiased estimator of P. X bar is an unbiased estimator of mu. How do we know that X bar is an unbiased estimator of mean? Because the mean of the sample means equals the population mean. The mean of the sample proportions is equal to the... So we already know that those two estimators are unbiased. That's why we can use them, okay? And so that's again where that sampling distribution concept was important. So what was the logic of confidence intervals? We looked at this yesterday. By the way, Lee, that's the one that you don't necessarily need.
Well, that's the beginning of the notes.
Well,
Yeah, I still need the beginning of the notes.
do you trust me?
No. Yes.
Oh.
Sort of.
Remember how I said that I accidentally printed the wrong one first? I reprinted it. Alright,
Okay.
so what's the logic of a confidence interval?
Basically, the likelihood to being the point estimator is almost zero.
I would say, what is the probability that p hat is equal to p?
Zero.
It's basically zero, and I don't even really have to put approximately equal to. It's zero, right? It's a continuous interval, so it's very unlikely for that to happen, so what do we do instead? We create an interval that's doing what?
Trying to capture.
Capturing the parameter, the population value. And so we looked at this yesterday. What's in the center of our interval?
The center of the
Point estimate. The point estimate, right? That estimate is at the center. And what do we do to that estimate? We
take the standard error.
We add or subtract the, and it's something related
Margin
to
of
this.
error.
There we go. The concept is that margin of error, and it's related to the standard error. We're going to talk about that more over the next couple of days. But remember that margin of error is what allows me to have p hat in the center, and then I have a lower bound for my interval, and I have an upper bound. So this is where the margin of error ends above, this is where it ends below. And so we're creating an interval that we are confident, or a certain level of confident, that's capturing the parameter. Apparently I just need to get a new remote. I wonder if it's because I have a newer laptop. Alright. So what?
I did the whole front page.
Okay. So here was that homework assignment that I left y'all with. What proportion? So first off, interpreting. So I'm just going to read this out loud. Remember, there's a formulaic way to interpret an interval. Alright? So it says, what proportion of American adults think it is okay to post spoilers about a new movie on social media within 48 hours of its release? According to a Morning Consult poll from October 2020, a 95% confidence interval for that proportion of American adults who think it is okay is 0.34 to 0.38. Now I'm going to go ahead and tell you this. What I'm actually about to write on the board is incorrect. I need you to find what's incorrect about it.
It's incorrect.
Thank you. With 95% confidence,
I'm 100% confident.
the moviegoers.
Are they supposed to be like, we are 95% confident?
You can just. I will say you can say we are or just with 95% confident. It's that's a language thing that doesn't matter a ton. But good catch on that, because I think in the book it very clearly says we are or I am 95% confident. That's acceptable. The moviegoers polled the proportion, I should say, the proportion of moviegoers polled.
Do we know it was moviegoers?
So let me reword that, because that's not what I'm trying to get you to. The proportion of American adults polled who think think it is okay to post spoilers within 48 hours of a movie release is between 0.34 and 0.38. I don't know if that's, I think the way they have it is they do the interval first, but it's fine. And then context at the end. What's wrong with this though?
It's about right to me.
Yep, there's major error.
Oh, polled,
Why is that a problem?
because it's supposed to be the population.
We need to be careful with our language. This is the most common mistake that I make. This is the most common mistake AP statistics students make. If I'm talking about the American adults polled, is that every American adult? No, that is literally our sample. I don't need a confidence interval for the sample itself. I know what the proportion was. It was 0.36. Right, because it's in the middle of that interval. Be careful with your language. With 95% confidence, the true proportion of American adults who think it is okay to post spoilers within 48 hours of a movie release is, I say between or is captured by is a better, by the interval. 0.34 to 0.38. Be very careful, okay? Tyler, does that make sense? And that's why I specifically did that language, because I make that mistake even, and we have to be careful about it. Like I always go back and I read it to make sure, did I make it about the population or did I make it about the sample? You have to make it about the sample. All right, questions about that? I think somebody said 9B they had a question about.
Yeah.
Yeah. So point estimate. Where is my point estimate always going to be within that interval?
Oh, I meant like on the middle.
Oh, on the homework. Got it. Look at that in a second then. I thought you meant here. Point estimate. What would be my point estimate? P hat equals
0.36.
0.36. The margin of error, actually usually just say ME for margin of error. What's going to be the margin of error then?
0.01.
Not 0.01,
0.02.
0.02. Remember, the margin of error is standard error and what we call a critical value together.
Okay.
So margin of error is just how much we add or subtract to either side.
Okay.
We have not, what you did yesterday when you did 2 times the standard error, that altogether is my margin of error.
Alright.
Yeah.
Wait, so how did you get the margin of error?
So remember the interval is P hat
Yeah.
plus or minus the margin of error. So the P hat's in the middle. That was the 0.36.
Yeah.
So what am I adding and subtracting to get 0.34 and 0.38? 0.02. Right? So the margin of error is just how far it goes to either side of that point estimate. Okay? The margin of error is just how far it goes to either side of that point estimate. So here's a question for you. Is there convincing evidence that less than half of American adults think it is okay to post spoilers about a new movie on social media within 48 hours of its release?
Yeah.
Why?
They're 95%
The
confident.
fact that they're 95% confident and the entire confidence interval is less than like 0.5.
Ah, with 95% confidence, right? The true proportion is less than what? 0.5. So that's pretty strong evidence that less than half of Americans think it's acceptable to post those spoilers within 48 hours. That entire interval is below 0.5. We're 95% confident.
How did they determine that confidence level? Was that just an arbitrary value?
No, that's a great question. So remember yesterday, and then Payne, I'll get to your question. Remember yesterday how Ashton talked about the fact that we have our standard deviation, right? And how many standard deviations did he go to either side?
Like 3.
I think he did, Ashton, didn't you do 2?
Yeah, I use 2 because that's where 95%.
So we went 2 below and 2 above, using that empirical rule, and so it's 95%. So it's based on how many standard deviations, which is also why we need a normal distribution, right? That doesn't work if it's not normal, but if we have a normal distribution, then we can go 2 below and 2 above, and we know roughly 95% in between. Now we're gonna, and so that's known, remember I talked about it just a second ago where I talked about 2 times the standard error is my margin of error. This right here is what's gonna tell us what the confidence level is. We're gonna talk about that more today. Peyton, then Bryson. Peyton.
Never mind.
Okay, you sure?
Mhm.
Did I answer the question or you just figured it out?
Yeah, I figured it out.
Okay, Bryson.
Can you restate what you said for C? You said with 95% confidence.
Yeah, with 95% confidence, the true proportion, right, is less than 0.5 since the entire interval is less than 0.5. So with 95% confidence, our true proportion is captured by that interval. Well, that entire interval is less than half. So we believe that less than half of Americans think it's okay to post within 48 hours. Okay, 9B you said, Deacon?
Sure.
Okay. So 9B's up here. So this is the same thing we just looked at, Deacon, but, yeah, chapter 8. But this is just dealing with means instead of proportions, but it's the same idea with the interval idea. So the question here with 9B is, So we have a true difference in the mean number of pairs of shoes is captured by captured by this with 95% confidence. So does the confidence interval give convincing evidence of a difference in the true mean number of pairs of shoes for boys and girls? So if there was no difference, what would we expect this to be? If there was no difference.
0.
So if they're the same, the difference would be 0, right?
Where's the, I can't see the thing, what's the, like, subscripts?
That's supposed to be girls and boys, right? So the mean number of shoes of girls minus the mean number of shoes for boys. And if I think there's no difference between those two means, the difference would be 0. But look at my confidence interval. Is 0 captured by this mean difference? No. So is there convincing evidence that the difference in the true mean number of pairs of shoes for boys and girls, or that there is a difference? Yes. Yeah, right? Apparently, I believe the true difference in the mean number of pairs of shoes for girls and boys is 10.9 to 26.5, with girls having more shoes than boys. How do I know it's girls having more shoes than boys? Because it's positive, right? If it was boys having more, then the difference would be negative. Does that answer your question? Okay. All right. Then I asked you to look at these notes. So how do you interpret a confidence level? We looked at this yesterday with the applet. In other words, what does it mean to be 95% confident? And interpret the confidence level for the spoiler alert example. So don't forget, use your textbook. Right? Confidence level is earlier in here. We'll talk about that later. Confidence level. Nope.
So what's the difference between confidence level and interval?
So remember, the confidence interval is the values, right? So I believe the true proportion is captured by 0.34 to 0.38. That's the interval. What level of confidence do I have? So the level is the 95%, right? And so notice it says to interpret a confidence level, if we were to select many random samples of the same size from the same population and construct a confidence interval using each sample, about what percent, or about that percent of the intervals would capture the parameter in context. I'm going to make that a little bit easier, but I need you to understand that's what we did yesterday on the applet. Remember how we did lots and lots and lots of samples? Right? And when it was a 95% confidence level, how many of those intervals captured the parameter?
Roughly like 0.95.
Roughly 95%, right? When it was a 95% confidence interval, roughly 95% of the intervals capture the parameter. When it was a 90% confidence level, what percent captured the parameter?
90%.
About 90%. The confidence level tells us how confident we are if we did this many random samples of the same size. Why, by the way, why does it have to be many random samples of the same size? Why can't it just be 1 or 2?
Law of large numbers.
Law of large numbers, right? Like the true proportion is approached, or the true probability is approached in the long run. Not when we have 10 samples, not when we have 20 samples, not 30, 100, 1,000, 10,000, 100,000. As when we go further and further, that's when we get there. So here is the idea of interpreting confidence level. Was there a definition for confidence level earlier? No. Oh, there it is. So there's the definition, right, for confidence level. Notice again, every time that there's a key word, it's defined in the textbook, and I did post it yesterday. So the confidence level gives the overall success rate of the method used to calculate the confidence interval, right? So if we have a 95% confidence interval, what proportion of my confidence intervals should capture the parameter? 95%. If it's an 85% confidence interval, what percent should capture the parameter? 85%. And so there's that definition, which, did the book ask for the definition, or the notes?
No.
Yeah, that's about the interpretation, right? So let's actually interpret the problem we were just looking at with spoilers. So how would we interpret our confidence level? And that's not the right spot. And the AP exam will ask you about interpreting confidence levels versus confidence intervals at times. So you've got to be careful about the difference. So how would we interpret this confidence level? Don't make it harder than it is. Read it off.
If we were to randomly select many random samples of the sample size from the same population and contract
A 95% confidence interval using each sample.
about 95% of the intervals will capture
True proportion of American adults who think it is okay to post spoilers within 48 hours of movie release. That's it. Now, I will not write out that much, I'll go ahead and tell you, okay? I would say something about, in the long run, 95% of confidence intervals will capture or using this same size will capture the true proportion, right? So in the long run is the key there. So in the long run, random samples of the same size will capture the parameter blank 95% of the time. Yes, sir.
It's just a question I will think kind of that you know I've talked about already, I forgot, but because we know that 95% of our confidence is 2 standard deviations to each side, so does that mean we're like, because it's the SCP rule, does that mean we're assuming that it's all normal?
That's a great question. We're going to talk about conditions today, so hold on to that
Can you
question.
repeat that one more time, Mr. Kenny? In the-
How I would word it, in the long run, right? In the long run, random samples of the same size should capture, or in the long run, confidence intervals of random samples of the same size should capture whatever the parameter is about 95% of the time. I will say, it might just be better to go off of that. But the idea is that if we construct a 95% confidence interval repeatedly in the long run, about 95% of those intervals will capture, and then you always have to put the context. And so, Bryson, it may just be more efficient, I will say, just follow that format.
Yes, sir.
It doesn't have to be perfect language, but you do need to be attentive to a couple of details, random samples, same size. Because if it's a different size, will it be the same interval? No. Remember, we talked about yesterday, if it's a higher sample size, what's that going to do to my margin of error? It's going to decrease it, right? It's going to make it more precise. If it's a lower sample size, the margin of error will be wider to get the same level of confidence. Okay. Now, I need you to pay attention to this question, the next question in the notes, because this is super important. It is also in the textbook on the very next page, but it says, does the confidence level tell us the probability that a single interval includes the parameter, captures the parameter?
Yes.
Probably,
Yes.
yes.
In the long run.
Okay, so notice it's in the long run, it's many intervals, right? Think about it yesterday. When you did the applet and you did a sample, it either captured the parameter or it did not, right? A single sample either captured the parameter or it did not. So if it captured the parameter, that probability is 1. If it does not capture the parameter, the probability is 0. So is it ever okay to talk about a particular interval? It's not. That is actually one of the things I've seen on the AP exam that I've been taught by people who do the AP exam. And so it talks about it again right here in the textbook. the confidence level does not tell us the probability that a particular confidence interval captures the population parameter. Notice right here, once a particular confidence interval is calculated, its endpoints are fixed. And because the value of a parameter is also a constant, a single confidence interval either includes the parameter, probability of 1, or it doesn't include the parameter. It's about the long run, it's not about the short term. It's not about a single interval, it's about many, many, many intervals. Okay, so it's not a single interval, it is many, many, many intervals. That is a small but important detail that I missed for the first 2 years I taught this class. We just want to make sure we get those small details right so we get those points. Alright, what was the next question? Margin of error, was that what it was all about on the notes?
That says would we prefer a small or large margin of error?
Yeah. So, would we prefer a small or large margin of error? You tell me. Would you want a large margin of error? Like when we're looking here, is it better to have a large margin of error or a smaller margin of error? Why would we want a smaller?
It means that your results are more precise.
It means that my results are more precise. Also, like I have, like if I were to have an interval of 0.3 to 0.42, how much information does that really tell me?
Not like.
Not much, right? We want a smaller margin of error. So what are the two ways that we can get a smaller margin of error?
Increase sample size.
So if we increase our sample size, that's going to decrease our margin of error. But what's a problem with increasing our sample size?
Harder to read.
It's harder to do. And when we say harder to do, I mean it takes more time, it takes more money. Right? If you want to get a sample of 5,000 people, that takes way more time than getting a sample of, say, 500 people, which means it takes more money. But it would give us more precise results. Anyone know or think of another way that we could get a narrower margin of error?
Use less.
Lower confidence?
If you lower your confidence, right? Like so yesterday, Ashton talked about 2 standard deviations to either side, right? And 2 standard deviations to either side, or standard errors, gave me a 95% confidence. But what if I only went from 1 to standard error below to 1 standard error above? You'd only be 68% confident. Is that going to be a narrower confidence interval?
It's also
Yes.
less accurate.
But it's way less accurate, right? So are there downsides to getting a more narrow confidence interval?
Yes.
Yes. Either we're going to be less confident, or we're going to spend more time collecting the data. Right? And so that's what we want to notice here about getting a narrower interval. So yeah, it'd be great to have a narrower interval, but we have to balance things. Now that's more big ideas. That's not something they're going to test you on the AP exam, but it is important to note. Notice if I wanted like a 99% confidence interval, roughly how far would I have to go to either side? 3 below and 3 above, right? But what's that going to do to my interval? It's going to increase the width of it, right? And so that's what we need to be aware of is there are costs associated with more confidence. There's costs associated with lower confidence. Keep those details in mind. And guess what? Next few pages talk about that. So what affects the margin of error? I will point this out. Have you ever noticed how I mostly skip these applets and the examples in the book a lot of time? Like, that's not good. Like right here, what's your GPA? I focus, if I were you, in terms of studying, I would focus on the explanation of things. That's going to cut out a lot of the reading. So why sell for 95% confidence when estimating an unknown parameter? And they talk about it down here, after all of this, right? The price we pay for greater confidence, which we saw this yesterday, is a wider interval. If we're satisfied with 90% confidence in our interval of plausible values, we'll be narrower. And so it's very rare that we'll go to 68%. I'm gonna show you today how to get what's called a critical value for 90% and 99%.
So I guess our critical value for 68% confidence would be just 1.
Yeah, negative 1 and 1. It's really close to that, I think. I have to go and effectively, or really check it. I will say, for 95%, it's not actually negative 2 and 2, it's 1.96. We're gonna look at that today, though, and talk about why that's the case. Notice this is a good note here, right, at this detail. It says, larger samples generally yield narrower confidence intervals at any confidence level. The width of a confidence interval for a proportion or a mean is proportional to 1 divided by the square root of n. So if you quadruple, right, my sample size, it's only going to cut the margin of error in half. Where are they getting 1 divided by the square root of n? Any guesses? Yeah, think about your standard deviation formula, right? Standard deviation of the sample means is the population standard deviation divided by the square root of n. The standard deviation of your sample proportions is p times 1 minus p divided by n, divided by the square root of n. So that's why, even if I quadruple, it's really only going to half my margin of error, right? Yeah. So if you if you double, it's not going to, if you double your sample size, it's not going to half the margin of error, it's going to divide the margin of error by the square root of 2. So, small detail, but useful to note. That won't be on a free response, but that could be a multiple choice question. The big idea that we need to notice is this. We prefer an estimate with a small margin of error, but that either means a lower confidence or a higher sample size. We generally prefer a lower margin of error, but that means either a less confident interval, or a higher sample size. Somewhere in the notes is at the end of that, yeah, roughly the end of that page. So the last question is this. Does margin of error account for bias?
No,
Why not?
because if it's biased,
It'll repeatedly miss the mark. If it's biased, it's going to repeatedly miss the mark. It's going to miss the parameter. So in the past, when I've done this globe activity, the confidence interval, which I think it was just because of sample size, usually we should have done a larger sample size. Usually the confidence interval is something like this for the proportion of ocean, right? But what's the actual proportion of ocean in the world? You know I'm teaching, right? Okay. So it's 0.71. So would that interval capture that? No. Why? Because this globe, is it accurate to the world? No. Right? And so this would be a biased method. What does the margin of error account for?
It accounts for differences in
Sampling
the
variability.
actual samples.
So the difference in the actual samples, which is called what?
Sampling
Variability, right? Every sample is a little bit different. The margin of error is accounting for sampling variability. If your method is biased, it doesn't matter if you do all the other stats right, if your method is biased, your data is crap. That's the best way to think about it. If your method is biased, your interval and your data is not going to work out. It only accounts for, the margin of error only accounts for sampling variability. Yes,
What
Bryce?
do you mean by your method being biased?
So like here, right? So this globe is not accurate to the world, right? So there's going to be measurement bias because I'm not going to be able to accurately measure what proportion of the Earth is covered in ocean, right? If you do convenience samples, right? That was a biased sampling method. So it doesn't matter what my interval from that is, it's bad data. If I do a subjective sample where you choose things, that's bias, and so the data is not going to be accurate. If you do something which is the response bias project that you're working on, which your goal is to introduce bias, but if you ask questions in a certain way that affect people's responses, are you going to get accurate data? So your interval's going to suck. It's not going to be accurate to the proportion. So like if you ask, for example, hey, if your question is, hey, what proportion of high schoolers drink on the weekend? If you ask them that to their face, how many of them are going to admit that? Well, students might admit it to other students, but like if I were to ask that question, would students admit that to me?
No.
But if it was anonymous, would they be more likely to respond honestly? Huh?
Alcoholics Anonymous.
Yeah, but would you be more likely, or would a student be more likely to respond with the truth if it was an anonymous survey?
If they believe that it's anonymous.
Right, and so that's important, right? But my point is still this. If there's bias involved, is your data going to work out?
No.
So the interval will not work out either.
You said the margin of error only accounts for what?
Sampling variability. Margins of error only account for sampling variability.
5% is
The penny's money.
Okay? And so, again, pay attention to the drawbacks to these actions for margin of error. Pay attention to the margin of error does not account for bias, only for sampling variability. Huh? Yeah. All right. So there's the homework associated with this lesson. All right. So we have pages 552 to 558 out of the book at this point. We're finally moving into 8.2. So 8.1 was just the basics of confidence intervals. We're now about to get into the details of confidence intervals specifically for proportions. And so remember earlier also when you were asking about, what was the question you asked? Do you assume normality, right? So first, let's look at this. Does anyone have a guess what the name of the procedure we use when calculating a confidence interval for a proportion might be?
Proportion confidence.
Super close, right? We don't do original things. In stats, we try to make it what it is. The one thing I'll point out is this. I just need to... Hold on.
I think it's on the foreman sheet, it's under the confidence interval.
So, hold on one second. I just want to change this to not using percentage view. All right. So two things. One, we haven't talked about critical values yet. We'll have to come back to that. So, here we go. Constructing a confidence interval for P. There's the name of it. So, we're going to talk about this Z interval. Hold on. Okay, critical value comes up later, so that's what I was wondering. So it's called a one sample Z interval for a population proportion. And there's a formula for it. Notice, what do you think this P hat means right there? Or what is P hat in terms of what we've studied?
It's your point estimate.
That's your point estimate, right? So what is... So there's my point estimate.
Abbreviation
For what?
for that.
Well, I'm going to show you something in a second. So hold on, write the name down. I'll show you something in a second. So there's my point estimate. So what is this piece right here?
That is the
This a what?
Z interval.
Hold on, I can't hear you.
It's like the Z interval.
So this isn't the Z interval. Notice there is a Z here, but come on. If this is my point estimate, what is this whole thing?
Oh, margin of error.
There we go. There's my margin of error. Right? We take a point estimate, we add or subtract a margin of error.
Is this on my foreman sheet?
That's a great question. We'll look in a second.
Going to burst.
Okay? Within that margin of error, what is this piece?
That's
That
your,
is the standard error.
There's my standard error. there's my standard error, or S sub p hat. So breaking down this formula. And by the way, there is a question on the notes about the formula. It's the third question down. What's the general formula for a confidence interval in AP stats? Oh, actually, that's specifically for p hat. The general formula for a confidence interval. Get out your formula sheet, and I'll answer Peyton's question.
What is the little star value?
That's what we're talking about in a second.
Hold on. Stop adding symbols in
Well, there's a reason why it's a Z star.
there. Letters was enough, and the signal was my breaking point.
Nope. Alright, I need you to have your formula sheet out. Does anybody see anywhere on this formula sheet that might tell me a confidence interval?
The bottom.
Confidence.
Bottom of the front side, right? What does it say the confidence interval is? Okay, so let's think about this. Confidence interval, it is a statistic. What is a statistic? Another word for that?
Point estimate.
It's my point estimate. My statistic is my point estimate. What comes next?
Plus minus.
Plus or minus? It says a critical value. And then times what? Standard error. And so when we put that critical value with that standard error, what do we get?
Margin of error.
Margin of error. Okay. We'll talk more about this in a second, but I need us to recognize the statistic plus or minus the critical value times the standard error. That's my confidence interval. That's what it is in general.
That's relative to Z-score, I think.
Say again.
That's relative to Z-score.
Mm-hmm. Close.
Yes.
Yeah. It is a Z. I'll explain why I say close in a second. So
It's a standardized value.
it is a standardized value, which what is a Z-score? A standardized value. So there's a slight difference in why we'll use that language. Right here though, I need you to pay attention to this. Which part of this interval formula is where my confidence level is going to come into play?
Critical value.
The Z-star, the critical value, right? Standard error is standard error, right? The statistic is the point estimate. This is where my confidence level comes from. The critical value is where my confidence level comes from. I should say, it's not, so I'm going to be careful with this. The critical value is not the confidence level, but the confidence level comes from the critical value. Does anyone remember what our proportion of ocean that we got in our sample proportion yesterday? Something out of 149 maybe?
Wait, what is that?
97 out of 146.
Okay, 146. And then remember how Ashton had us do 2 times the square root of, it'd be 97 out of 146. There's my sample proportion, times 1 minus that 97 out of 146.
0.5.
Notice, this is my what?
Or-
That's my, this part right here.
Yeah, that's,
Oh,
point estimate.
That's my point estimate, right? Okay, that was my statistic. This right here was my
That's
margin of, well, not this part, just this part.
Just that part, the standard
Oh,
error.
That's just the standard error.
And then that
This is my
critical.
critical value. And we said because we did 2, roughly what was our confidence level?
95%.
95% based on the empirical rule, right? The critical value is what tells me my confidence level. Because I went 2 standard deviations to either side at a 95% confidence level. Okay? Questions about that so far? Go for it. Now, here's what I need us to recognize. what symbol do they use for that critical value?
Critical value.
That
Z star.
Z star. The reason why it's a star is because it's a critical value. It's not Z, I'm not calculating a Z score, but it is a critical value. Now here, let's find out how to actually get this critical value for any level of confidence. So let's say I want 95% confidence. Again, it's based on a normal distribution, right? With 95% confidence, where are we seeing that 95% in this normal distribution?
Z star will equal 2.
Close. But what am I seeing in the graph when I just say 95%? Is the 95% a Z-score or is that an area? Okay, so I need to recognize what I'm looking at is an area of 95%. And so it is very close to 2. But remember I said earlier it's not exactly 2. Okay? So what I'm looking at though is a 95%. That's 95% or 0.95 for my area. And so I need to figure out what is this Z star. How can I use this drawing, which again is why I said draw normal distributions from the beginning. How can I use this drawing to help me find what that Z star actually is?
Inverse.
Yeah.
I can use an inverse normal, but when I use that inverse normal, what area do I need to put in?
95.
Not 95, that's where you need to be careful.
That,
Remember,
Oh, 0.05.
super close.
I'm confused.
Okay, so inverse normal, and this is what I need you to remember. Inverse normal always takes the area to the left. So not the area in between, but I can get my critical value right here by looking at the area to the left. And 0.05 is closer, but it's not 0.05. Where are you getting that 0.025 from, Joseph?
Because it's half of the 0.05.
Notice 95% is in the center, right? 5% is on the tails. But I have how many tails? 2. So I need to put this area in. I need everybody to pick up a calculator. I need you to go through the inverse normal, and I need you to find what is my critical value.
Negative 1.95.
You did that so
9.
Well, you just already did it.
How
Wait, you said
many
negative
how
1
many
point?
values do you
Yeah, that's a
want?
good question. So area and proportions, we do 4 decimals. Z-scores, we do 2.
Alright, so here 4. Okay, well then, I guess I'm like negative 1.9599.
Remember, Z's, we do 2.
Oh,
Areas
yeah.
or proportions, we
doing
do
Z's?
4.
Okay.
Mr.
What are we solving for?
I've always been confused about this. Which one do we put the
So remember, the reason why I like to use the standard normal curve is because it always has a mean of 0 and a standard deviation. That way it does, so like, guys, hey guys, do not forget, the reason why I always have you go to a Z-score is because a Z-score is on the standard normal curve, which has a mean of 0, standard deviation of 1. You don't ever have to change that if you convert it to a mean of 0 and a standard deviation of 1. Okay? Huh? Inverse normal. Oh, like where are we? Talking about critical values. Guys, we're on this section talking about critical values. Sounds like someone.
I love sleeping.
They'll come back for it, I'm sure. Alright, so what do we get for Z?
Negative 1.9599.
And when we do a Z, we usually stop at 2 decimals. Does anyone recognize that number?
It's almost negative 2.
It's almost negative 2, but I think I said this number earlier. I said it was going to be 1.96. 95% confidence level is the most common confidence level that we use. You need to know that 1.96.
So what would we write on the AP exam for how we found this?
You won't have to do that. Because so the Z-score, like if you're trying to get that critical value, it's going to be 95%, so it's going to be 1.96.
So how do you calculate the critical value?
So remember how we had to find the area to the left of my critical value. And technically you do positive or negative, it doesn't matter. But we had to find the tail area. So let's look at this. What about if I wanted to do a 90% confidence interval? That's another common confidence interval.
0.05.
So if I draw my normal distribution out, what's in the center? 90%, right?
Yeah.
And so remember, I need to use that inverse normal. I need to know what percent's in this tail. What percent would be in this tail?
0.05.
Why do you
So 90%'s in the center, right? How much is in both tails? Well, sorry. If I look at both tails together, it's gotta be 10%, because it has to add up to 100%.
Yeah.
And so I split it in two.
Okay.
And so now, do inverse normal with this area.
Negative 1.64.
That's plus 92.
The only reason I do the 645 is because I've seen them do it regularly where they do 3 decimals for that one. Why do they go 3 there? I don't know, they just do. So, the z-score associated, or the critical value associated with 90% is 1.645. I now want you to find the critical value for 99%.
We did this.
What we use for
Yeah, with chi-square distributions, right? Okay.
Should
So I need you to find your critical value. By the way, if I'm doing critical values, I'm still going to draw my normal distribution. It's going to help me identify these pieces.
Close up to 3.
No.
I know how to do that.
Mr. Kenny.
Because that's how they calculate it.
What's,
Something like that. Is that for 0.99, so you just?
So remember,
you think?
so right here, Bryson,
None of it.
this one is the negative 1.645, so this one would be the positive 1.645. So what you could do is you could do 0.95, but it's always just the area to the left. And so that's why we did this and just the area to the left.
Because you got it.
And so it's easier to do one tail rather than the middle and left. Alright, so for 99%, come on, we need it. So what area did we put in for a 99%?
Yeah.
0.005, right? If you draw out that normal curve,
We're just gonna do whatever's left.
what percent do we have in the center?
99, right?
Oh.
Divide it by.
The area 0.99?
You get inverse.
And so what's in both tails at the same time? 0.01, but I gotta split it into two. And 0.01 divided by 2 is, right? And so that's the area you're gonna put in. And so that z-score is negative 2.576, am I remembering that right?
We just remember that.
Because, so, have y'all heard of Pythagorean triples, I hope? The 3, 4, 5 Pythagorean triple, right? There's a 5, 12, 13 and an 8, 15, 17. Those are the 3 most common, and 6, 24, 25. Those are the most common Pythagorean triples. Those are the most common confidence levels. And so I learned them. Remember how you remember 68, 95, 99.7 from the empirical rule because those are common? Those critical values are the most common critical values we use. 95% is the major one, just like 3, 4, 5 is the major Pythagorean triple. Alright. How do we feel about finding those critical values?
Pretty good, pretty good.
Pretty good, pretty good. One thing I'll point out is they talk about critical values in 8.1, not in 8.2, so I need to update those notes, okay, to include that information. But when I take a critical value and I put it with my standard error, what do I get? Critical value plus standard error gives me my margin of error. Critical value plus my standard error gives me my margin of error, right, Deacon?
Joe, sorry.
So past that. Okay, so, last detail I want to point out is this. It says what is the name of the procedure we use when calculating confidence interval for proportions. Everybody pick up a calculator. What's the button that lets me do cool crap?
Menu.
Alright, hit that menu button for me. What course are we in right now? So go to statistics for me. Anybody see a useful button under statistics? Holy crap, there's a confidence intervals option?
Yes.
Oh my gosh. Why don't you go to confidence intervals real quick?
More freaking.
Does anyone see one there that might be what we're going to do? Super close. Keep looking. Maybe look at number 5. What do you think one prop means? One proportion z interval. That's what I call it. A one proportion z interval. Why is it one proportion and not two proportions? Because we only have one proportion. Will we look at two proportions? Definitely. Yeah, we'll look at two proportions soon. Okay, one proportion Z interval is what I would call it. That's what I would write on the AP exam. You can write that longer thing from the textbook, but I'm going to call it a one proportion Z interval. So if you want to make that note about the name, that's useful because that's what's in the calculator. It's a one proportion Z interval.
Right.
Notice I don't just say one prop, I do say one proportion to help me remember that detail. Go for it, Deacon.
What is the standard error of p-hat measure?
The standard error? The standard error of p-hat, well, hold on. Is that a later question?
No, we
Comprehensive rules for
went past
proportions.
it, but.
At the top.
No, we're going back, sorry. Notice, what is the name?
It's usually
One proportion Z interval. So what are the random 10% and large counts conditions?
Those are things that apply to proportions.
They are things that apply to
Check
proportions.
for the norm. Independence and normal.
I would say two things. One, only one of these counts or checks for normality. Which of these conditions checks for normality?
Large count.
Large counts, okay? Guys, this is my condition to check for normality. Also, you remember earlier when you were like, do we just assume it's normal? No, we never assume. We check for that normality. Every time on the AP exam for free response, it will be normal. However, if you don't check it, you will not earn full credit.
So we only.
You have to check for normality. And don't forget, for proportions, what checks normality?
Large count.
Large counts. What checks for normality with means? Central limit theorem, or if the population was already normal. Okay? Josh, you had a question?
I was just gonna ask if we were using all of these, but I got that.
Okay. So large counts condition, right? What is the large counts condition?
N times p is greater than or equal to 10, and then n times 1 minus p is greater than or equal to 10.
So remember what this is saying is my expected success and my expected failure are both greater than or equal to 10. Now remember, Deacon, because I heard you starting to say if it's sufficiently large, what is the sufficiently large? That's central limit theorem for means, right? So we gotta be careful. Central limit theorem is sufficiently large. This is expected success and expected failure. But I need you to check that formula again. We got a problem.
That's the parameter.
Yeah, that's the parameter. Do we have the parameter?
No.
No. In fact, we wouldn't have to do a confidence interval if we had the parameter. So what do you think we're going to use to check for normality here?
Yeah.
P hat.
And you can say that with.
We have to use the sample proportion when we are dealing with confidence intervals because we don't have the population proportion. You need to make a note of that this formula changes to P hat with confidence intervals because we don't have P. So we have to use confidence, or we have to use P hat with confidence intervals because we don't have P. The whole point is we're trying to estimate it. I need you to pay attention to that detail. Okay? Go for it. Yep. Random. Well, we've already talked about this. If you don't really have a random sample, what's your data? It's crap, right? It's what? It's biased, right? Does anyone remember what the 10% condition was for?
Independent.
It was something about independence. Specifically, it's the idea that if our sample size is less than 10% of the population, then one sample or one selection doesn't really affect the next. Does anyone remember what that's important for, though? Okay, so you have the rule down, but the thing to be aware of and to remember about this is that 10% condition allows you to use this formula. If the 10% condition is not valid, you cannot use this formula. The standard deviation of P hat, which means that you then could not use the standard error formula. So if you violate the 10% condition, that standard error formula is not valid. Okay? You guess where we can find all this information?
Oh my god, in the book.
Oh my gosh, it's in the book, right? I need y'all to understand, right? This book is a great resource. It explains things in extra levels of detail that you may need. right here, which I'm gonna cover this up and I'll bring it back in a second. So right here, I want you to see, what does it have right here? The random condition, right? If our data is not random, is not from a random sample, or if it is from a random sample, we can make an inference, a prediction about what? The population. But if it comes from a convenient sample or voluntary response sample, we should have no confidence. For p hat to be valid, we need to reduce that bias. And so you have to check the random condition. And you know what it's going to say on the AP exam every time? A sample from, or a random sample, or they still have a simple random sample, or something to that effect. But you know you still have to write down that it's a random sample. You have to. You have to check that condition. Notice the next part here is 10% condition. Oh, I will make a note here. If it's a stratified cluster or systematic random sample, it is a much more complicated situation, so the AP exam doesn't do that to you. If they say simple random sample, they mean it's a, or if they say random sample, they mean simple random sample. Notice here 10% condition. When the 10% condition is met, the standard deviation of the sampling distribution is approximately that. The 10% condition is about independence, right? But the idea is, if you were to select from an infinite population or select from a population with replacement, one selection does not affect the next, right? But if you do it without replacement, right? If I were to sample this room and do it without replacement, what is the likelihood that I pick Joseph? I think we have 12 right now. So 1 out of 12, right? Okay. But then what would be, so he's now out of the population, so what's the likelihood that I pick Lexi? 1 of 11. Those are different probabilities, aren't they? Different proportions, and significantly different enough that the standard deviation formula would fail. If I were to just look at what is the probability of selecting a girl, right? I currently have 3 out of 12 of us.
I don't like it.
I know, I'm sorry. But we have 3 out of 12 of us, and so what's the probability of the second person I select being a girl? 2 out of 11. That's a very different probability, right? So the 10% condition is about making sure that standard error formula is valid. Notice they give a good definition here of a standard error. We've used this idea in the past, but what is a standard error? It is just a... Yeah. So it's a standard error statistic. It is the standard deviation when a statistic is estimated from the data. If it was from the population, it would be called a standard deviation. If it was a standard deviation of the sampling distribution, right, it would be from population. But because we're having to use a statistic, we call it a standard error. And they lay that difference out on the formula sheet. Right? Oh, the other side, sorry. If you look at the formula sheet, notice how they have standard deviation, sigma, and right next to it on the right is standard error. Right? So on that formula sheet, they lay it out. Pay attention to those labels. Anything I need to clarify off of this page? Oh, this page. So far. I'd say that's no. So we now have it. What 2 factors determine the margin of error?
Sample proportion and critical value.
So it's not the sample proportion. Think about that again. The sample proportions involved the standard error and the critical value, right? What 2 factors? My margin of error is my critical value times my standard error, or the margin of error is the critical value times the standard error. Now, this is only the standard error for proportions. It'll change slightly when we get to means, right? But it is critical value times standard error. So this was the question you had earlier, right? So what is the standard error? What's the symbols we use for standard error? S of P hat, right? So the standard error of P hat is equal to what?
Times 1 minus P hat over again.
Remember, that is quite literally my standard deviation, but instead of P, I have P hat. Standard error is just that. Go for it.
I may have missed it, but what does the star mean again?
Remember, that's your critical value.
Okay.
So it's not just a z-score, it's a critical value.
So it's the
So it's this, right? So it's the value that separates it's the value that gives you your confidence level, right? So going back to that normal distribution, it's the value that gives you the confidence level that you're interested in.
Okay.
So remember when we did 95%, we had that area of 0.025, and so that critical value was negative 1.96 or a positive 1.96.
Okay.
Okay, so
So
it's
it's
my
like this-
critical value.
Okay, so it's like z-scores?
It is connected to z-scores, because remember, z-score is that standardized test statistic where the mean is 0 and the standard deviation is 1. So that's where we're pulling this value from, right? But it's not calculated from value minus mean divided by standard deviation, it's just from the standard normal curve.
So what is z-star?
The critical value.
Okay.
This is all symbols, so yeah.
But just remember that critical value is from the standard normal curve. And look, when we have a standard normal curve, each of these values are a what? Each of these each of these values on a standard normal curve are a z,
Yeah.
right? Z equals 0, z equals 1, z equals 2. So we use z star for a critical value from the z-score, the standard normal curve.
Right.
Okay? So what is that standard error measuring? I'm going to tell you, that's one of those things that we need to be careful about, but it's right here. What is the standard error measuring? It is estimating the what?
Standard deviation.
Standard deviation of what?
Estimated value?
Not the population, not the estimated value. What was the standard deviation? Remember, it was the standard deviation of the sampling distribution, right? So what is this estimating? It is estimating the standard deviation of the sampling distribution of p hat, right? We need to be clear on this, that standard error, this estimates the standard deviation of the sampling distribution. And because it's p hat, it's for p hat. But it's an estimate of the standard deviation of the sampling distribution. That's what it is measuring. Which that corresponds to, so someone said population earlier, and it is how much p hat typically varies from the population proportion, but in what? Repeated simple random samples in a sampling distribution, right? So remember, it's how far p hat typically is from p. So guys, I need y'all to note that standard error is how much p hat typically varies from p in that sampling distribution. All right, we've done critical value, we've done calculating critical value. We have the specific formula already as well, right?
Yeah.
Okay, so let's talk a little bit about the specific formula. So first off, is the specific formula on the formula sheet? No. But what does the formula sheet have? We have confidence interval, which is what?
Statistic plus or minus product of critical value and standard error statistic.
So critical value times the standard error, right?
Yeah.
And so that's what they give us. Do they give us anything else though to help us out?
No, but you just gotta put it together from there.
So do they give you anything on that formula sheet to help you fill out the rest of this confidence interval? Do they give you the critical value on that formula sheet? I don't see it either. But like statistic, do we have to really worry about statistic? No, they tell us statistic. What else do we need though?
Standard.
Do they give us standard error?
Yes.
Yes, guys, standard error is the one part that can get nasty. But guess what they do? They give it to you. Right? No, remember, critical value, that's where you're going to draw that normal distribution. You're going to find the critical value using your tails. Okay? But that formula sheet has your standard error on there. Right? The formula has your standard error on there. That's what I need you to notice. The one part that's difficult, the formula sheet has on there. Now, I do want you to notice that this formula tells you the conditions you have to check. In order for our statistic to be valid, what kind of sample do we have to have?
Random.
Has to be random. For my statistic to be valid, we have to have a random sample. Okay? What type of distribution do we have to use a critical value?
Normal.
Has to be approximately normal, so that's which condition? Large counts. For normality. Right? Now remember, large counts only works for what type of statistic? Proportions. And then what condition is there for standard error?
10%.
10%, right? The 10% condition is for standard error.
So it must have been both of them.
And so we have to have all three conditions met to be able to use the confidence interval formula. And I want to emphasize, and I need y'all to hear me on this, and I need to do a better job of saying this in the future for future classes. Statistics, much like the way I teach math, it's not isolated formulas and isolated rules, which is how I feel like a lot of math is taught. All these things are tied together, and when you see the connections, it makes it way easier to remember everything. Connect your conditions to that formula. Connect your formula to the idea of a point estimate and the margin of error. Find the connections. It's going to help you keep everything straight. Any questions through this section so far? Going once, going twice. Okay. Alright, I want you all to work on A, B, and C based on what we have discussed. You can work at your groups or work at the vertical surfaces, 7 to 8 minutes, and then we're going to come back together so we can discuss before the end of class catches us.
Which one's gonna work at? You want the critical surface?
You guys tell us.
I'm just saying, up there.
First off,
Wait,
zero.
Okay, we can.
While we get started.
We're gonna find this out.
I think for the most part I got it, it just needs a little second.
Oh, like different conditions.
They're afraid the conditions. I'm not the set of go from myself.
Help.
Real.
Probably, I'm trying to go to, no, I got the dress for $13.
Excuse me, from where? Ross dresses or something?
Already 7.
Yeah, the ones I was looking for were
What color is
That
it?
is not.
they were like blue, like iridescent, like you know the ones you see on TikTok that like change color in the light. Those.
Yes. No, this year's prom theme is so bogus.
No, it's Miami nightclub thing.
Oh.
But she can't say Miami nightclub on a school board.
Yeah,
So Neon Jungle was the best we could do.
it's the synonym.
Neon get together, I mean anything? Party?
Okay.
Something?
Oh, wait,
This is,
That one's
this is it.
Neon jungle.
It's not the theme, it's Miami nightclub.
Is that what you're gonna?
Yeah, and then I'm gonna pin it in the back with like gold. It's falling apart. And that was more expensive than a car. That address could buy a house.
Let's hear like something about people.
And not even a year afterwards, it's falling apart.
10%, we would do like.
Okay.
Point three
How many do we
one
have to
seven
do?
three
Actually, it's-
Three.
I really
The last
don't know.
one is the Texas. No, not
No, it just.
Calculate 90% confidence interval. What proportion of US adults contribute to crowdfunding campaigns such as?
Might be right.
A random sample of 1,435 US adults, 487 reported they give to a crowdfunding campaign in a typical year.
No, large counts
Verify the
is,
conditions for calculating confidence
large
interval
counts is it.
for P are met.
Oh shoot, I got it backwards.
Random sample is random.
So, are we not
Well,
doing
then
the
it
same
doesn't
thing
satisfy
that we
those
did
counts.
a couple of years ago
Fill it in.
to calculate?
Well, the conditions that we need for if it's, our confidence interval is random condition and the 10% condition.
Random 10% would be
Is that,
the
is
large
it 10%
count.
or just it?
Well, it's a confidence interval. That's the 10%.
Yeah, it's definitely greater than.
I got it
less than
backwards.
10%.
Yeah, one.
Yeah, it's like the whole thing.
Three one seven three.
What number did they have?
So both are over.
It
Looks like
We're not
Jesus
given
Christ.
the population.
Which is above 10%.
Oh yeah, I guess it
Well,
has
that's
to
why I'm going to.
More than 18,000.
Wait, so it's large counts is like.
Oh, well, the 10% will be adjusted greater than 90 numbers, the 90%
Yeah,
What is it-
because
what does the
there's
10% rule say?
toxicity coming out of every deposit.
It's like.
This is saying that in the sample size is less than or equal to, or is less than what?
Like where Josiah used to live in Texas?
10% of the population. That's the 10% rule. N times P being greater than or equal to 10, and N times 1 minus P being greater than or equal to 10. That's my large counts. Now remember, it's P hat. But think about your sample size. Is 1,535 US adults less than 10% of all US adults? Okay, so 10% rule is kept as a condition. Large counts, again, you need to show this and you need to word this, is N times P hat greater than or equal to 10.
American funders of the US dollar bill.
So I'll point this out, you don't have to do any work. Remember, I call this the expected number of successes. Well, how many successes did you actually have? Just notice it would be 1535 times 487 out of 1535. Okay, and then if you check you subtract that 487 from 1535, because again, it's the expected number of failures now, it would be 1,000 plus, which is actually do the calculation. Now, I'll start on the next piece.
And 153.
So what's she looking for?
Like when you drew the distribution.
Yeah, I want to go 47.
Or here,
For
you
what?
don't ever do it.
90% confidence interval. So remember, so confidence interval, that's
This is like a 9.
the point estimate, or the statistic, plus or minus the critical value times the standard error, right? What's my point estimate? P hat, which is
487.
out of.
Wait,
So remember,
No,
you might want to
record
write
of
out the
still
formula
has
that P hat there, because it's going to remind you to do a proportion. Remember, 90% is one of the most common ones, so we want to know that critical value. But you can draw out a normal curve, because what's in the center? That
How do we know
90%.
that it's,
So C lower should be.
So what's in the tail?
977.
So that's all we need
Hang on, let me get mine too.
for that critical value. So normal, remember, for proportions is the large counts.
Okay, so.
Okay.
And then with, or like,
It's the same one we got.
what about the 10%?
So 10% says the sample size has to be less than what? 10% of the population. Is 1,535 less than the US, all US adults?
Yes.
So 10% condition is met. Okay, find your critical value.
Or is this the critical one?
So, hold on. What's our confidence level there for now?
Confidence level is 90%, so the area is 0.9.
Wait, so we put that in the calculator?
For my confidence level to do
Yes.
this.
For 90%.
Like here?
So it would be plus or minus.
So you could use that formula. So you're writing out that hand first, but yes, the confidence level would be 65.
But it's the 4 right there.
You round up.
You can't round up, because it's not above 5. If we use the inverse one.
6.4.
0.9
So
or
yeah,
5.
0.5 to 8, put 0.9.
6.
I can't remember if it said 95 or
5.
so 0.95.
And
What was
then
your question?
that'd be 1.5.
if I use the inverse, you go for the 0.05, because it's the.
Right, 'cause so
Okay, yeah, I'm
you
talking
can
about
eat, remember, it's always the area to the
second
left, so
four.
if you do 0.05,
Turns
it's
into
gonna
a
give you this
5.
negative 1.645. If you do it from here and to the left, it's gonna be the positive 1.645, either one.
I said 1.64.
If I need it, right?
So what's going on?
Wait, what?
I think we got it. Sweet.
One thing you need to be aware of on the AP exam is you need to show everything being substituted into the formula, and then I would use that calculator to do the rest of the work.
I did it wrong.
So like what I would do is, I would do p hat plus or minus c
487
times the square root of p hat times 1 minus p hat
times
divided
1
by n,
minus
and then I would
that
just
over
put
n squared.
487 out of 1535.
Could we round, so
You said that it's what times or plus or minus the same?
Put it into that.
Could, I like to write out the formula to help me
weird
remember what
star
the
formula.
formula.
The weird star formula, this one right here.
That's what.
No, you gotta.
Alright, if I can grab everyone's attention, we need to take the next 7 minutes to go over it. So, we definitely are getting a couple of things, or most of the things. I do want to point this out. Just a couple of details to make your life easy. First off, I like to start with writing my formula out. So, the AP exam has this on there. Take advantage of it. So critical value. And this is going to help you show evidence for both A and B times standard error, right? So the statistic, what condition do we have to have a valid statistic? Random. Does it tell us that we have randomness?
Yes.
Okay, I'm just going to put a check because they literally tell us random. But let's look at the next piece, critical value. What has to be true for that critical value?
Critical value
Has to satisfy the large counts for what? Normality. Large counts. Now, make sure when you write out this formula, we're not using P, we're using P hat. Why?
because we're dealing with,
We have sample proportions. We don't have the population, we're estimating the population. But I'll point this out, another way to remember this is my expected number of what? Successes, or my actual number of successes. I don't actually have to multiply anything. What was my number of successes?
47.
And so then what was my number of failures?
Number bigger than
A number, it was 1,000 plus, I would actually calculate it, but it's something bigger than 1,000. So, large count satisfied? Now you need to be careful about 10%, you need to actually check this. 10% condition is that our sample size is less than 10% of the what?
population.
Is 1,535 US adults less than 10% of all US adults?
Yes.
Yes. And remember, that's for my standard error, right? So each piece of this formula has a different detail, and so I'm checking a condition for each thing. So that is valid for my standard error. So 10% condition, and I would write it out, right? 1,513 to 35 is less than 10% of all US adults.
So it'll be something where you can reasonably assume.
Yes. Yes, that's a great question, but yes. Alright, so 90% confidence interval. A lot of y'all, and I'm glad we picked this up, we can just put this into the calculator. However, what you are going to want to do is you're going to want to write it out. They want to see, every time I look at a scoring rubric, they always want to see that you know how to set up the confidence interval. Now 90%, this is one of those critical values you want to learn. But again, if 90% is in the center, what's in this tail right here?
0.05.
0.05. So when we use that inverse normal, what's my critical value?
That'll be negative 1.64.
Okay. Yep. And so my p hat is 487 out of 1535, plus or minus my critical value times my standard error, which I always just leave this as a fraction because I'm not actually doing this by hand. And that way I don't even have to do any calculations. Now let's make sure that we know how to put all this into the calculator. Again, I'm not doing this by hand. So, what's the button that lets me do cool crap?
Menu button.
Alright, I need everyone to pick up the calculator and hit menu. I'm sorry that I'm moving fast. We got 3 minutes though. So hit menu for me. Under menu, where are we going to go? Statistics, number 6, under statistics. Number 6 for confidence intervals. And what type of confidence interval is this? 1 proportion Z interval. I'm going to give you a 4-step process to help you with this starting tomorrow. But notice, what is X the number of successes? 487.
That's 7.
Okay? Yep. What is N the sample size? 1535. Right? It's my sample size. And what's my confidence level? 0.9. 90%. 0.9. Notice the calculator makes my life real easy. And so what interval does it give us? What is it?
0.2977.
Comma.
0.3368.
And so there's my interval. Notice they give us a lower bound and an upper bound, I think is the language that they use.
Yeah.
C lower, C upper. Notice they give us margin of error, all those things. So, interpret the interval with 90% confidence. The interval of what? With 90% confidence, the
Teachers
interval
and
of
students, please pardon the interruption. Just a reminder that students who have the following
0.368
teachers
does
for
what?
their
What is that
enrichment
interval
class.
doing?
This is for juniors only.
Captures the true proportion of U.S. adults who contribute to crowdfunding campaigns. That's it.
I believe
Say
that.
again.
Ms. Aldridge.
I don't think so either.
Bolton,
That's just
Coach
an example. I would just stop at
Dallas,
crowdfunding
Ms. Hinton,
campaigns.
Mr. House,
Okay?
Coach Isom, and Mr. Langford. So please report directly when the bell rings to the theater.
So,
Thank you.
here's what I want to ask you to do. I want you to do a confidence interval, let's say a 99% confidence interval for the proportion of Earth that is covered in ocean. So 99% confidence interval. Check those conditions, do the whole 9 to make sure that it works, right? So do a 99% confidence interval and interpret it tonight. Come prepared tomorrow to start there. Okay? Make sure you interpret that confidence interval as well. I imagine most of us will need a calculator.
Oh, I gotta take it home.
Yes.
Can we take them now or do we need to?
Yeah, if you can come back later, do that, but if not,
I'll
go
come
ahead and
back
take
later.
it now.
If I remember.
Because my students at Algebra 2 can share today. When she said it's fair, Mr. Arliss, they can share today pretty easily. Okay.
If y'all like to contribute to my founding campaign of going to Cuba this year.
Sounds like fun.
Give you money?
Communism.
Well, my
Actually, I don't know.
grandparents did
It
speak.
is, but
I can give you some money tomorrow. How much money do you need?
$1,650.
I'll give you 50.
Alright, we gotta get through.
I'll give you a high five.
Thank you. No, we're installing water filters. I'm going with a church. We can pray for it.
Right for you.
Yeah, install water filters and have it up for gospel.
That is great.
Since I didn't tell y'all, we won't do a demonstrate understanding tomorrow, but be prepared for a demonstrate understanding on Thursday.
Oh.
Whoa.
What?
Okay.
Whoa. Who needs water?